Hello everyone. A boat of mass small m is anchored in the middle of a river which is flowing with a constant velocity v naught. Horizontal component of the force exerted on the boat by the anchor chain is T naught. The boat is anchored with a chain. If the anchor chain suddenly snaps, breaks, determine the time required for the boat to attain a velocity equal to v naught by 2. Assume that the drag force of water is proportional to the velocity of the boat relative to the water, and we have to neglect air drag. So we have the diagram. Let's show the forces initially acting on the boat. So depending on the orientation of the boat with respect to river, we can say that the river is initially flowing in this direction with a speed v naught, and relative to the river, the boat will be moving to the right with the velocity v naught relative to the river. So since the relative velocity of boat with respect to river will be towards right, a force equal to some constant k into v naught will be acting on the river, on the boat towards left. Also, the horizontal component of tension due to the chain is T naught. And so we can write that initially, since it is in equilibrium, so T naught must be equal to k into v naught. Also, as time progresses and if we snap the chain, if the chain breaks, then later on, when the chain breaks, let us say that this chain breaks. If it breaks, the speed of the boat, let us say at any instant, becomes v, whereas the river velocity will always be equal to v naught. So with respect to the river, the boat will have a velocity towards right, and now it will be reduced in magnitude. So the boat's velocity will be v naught minus v towards right, and drag force in magnitude, it will be k into v naught minus v. It will start acting on the boat towards left. So the relative velocity of the boat with respect to water is v naught minus v. So let us call it as vr. This is the relative velocity, and this relative velocity will reduce with time, and after some time, since the drag force is continuously acting, v relative will become 0, and at that instant the boat will be moving along with the river with the same speed v naught. In that case, the relative velocity will become 0. So we can say that the force is equal to k times v relative, and if we write this force, drag force, since it is decreasing v relative, so a minus sign will be there. So F can be written as mass into acceleration, so dv by dt, and this v will be relative, and on the right hand side this will be k into vr. Remember, vr is v naught minus v, the speed of the boat relative to the river. So if we do variable and separable, we can write minus m by k into d vr upon vr. This will be equal to dt, and if we integrate both sides, 0 to t, and on the left side initial relative velocity is v naught, and finally it is v naught by 2. So on integration we will get minus m by k and log of 1 by 2. This will be the time t. So the time taken, and log 1 by 2 can be written as minus log 2. So it will become m by k log 2, and k we can get from this equation. K can be written as, from initial conditions, t naught by v naught. So we can replace k. So the time taken will be k upon m upon t naught by v naught into log 2. So this will be the answer. So this is the solution to this problem. This is a problem from the book Pathfinder. I hope you get it. Thank you very much.